Hello everyone, I'm Gaganveer Singh and I'm going to show you how to create IFTTT webhook triggers with Arduino. But before we begin, let's quickly grasp what webhooks are. Think of webhooks as digital doorbells. Whenever a specific event occurs in one application or platform, it can ring the bell of another application, prompting an action. It's a way for apps to communicate in real time. IFTTT, which stands for If This Then That, provides an amazing platform for creating webhooks. With it, you can, for instance, set up your Arduino to send a tweet, an email, or even control smart home devices every time a sensor is triggered. It has many possibilities, like your plant's moisture sensor can send you an email when it's thirsty, or your home security system can flash your smart lights when an intruder is detected. Let's see how to create an applet using a webhook on IFTTT. First off, if you are new here, IFTTT stands for If This Then That. It's a fantastic service that lets you create powerful automations using what they call applets. Webhooks are a simple way to receive data or events from one app to trigger actions in another. First, head up to IFTTT website and sign in. If you don't have an account, sign up. It's free. In the search tab, type webhooks and select the webhook service. Here, click on documentation button and open it in the new tab. Take note of this URL. We will need it later to trigger our webhooks. Go to create option. Now let's define our if this condition. Click on this. Search for webhooks and select it. Select the receive a web request trigger. Now enter an event name. This is what you will use to trigger the webhook. For this, I am using a light sensor, so I am going to name it light intensity. Next, click on that to define what should happen when the webhook is triggered. For this tutorial, let's say we want to send an email whenever the webhook is triggered. So search for the email service and select it. Fill in the details for the email and click on connect. Review your settings. If everything looks good, click finish. To test your webhook, go back to the webhooks documentation page and use the provided URL to trigger the event. Replace curly braces event with sample event, the event you mentioned. I will going to use light intensity. Once you do, you should receive an email based on your applet's configuration. And that's it. You have successfully set up an IFTTT applet using a webhook. Now let's start with the code part. Starting with the comment block. It's always a good practice to attribute your code. It helps others know who the author is. The Wi-Fi Nina library allows modern Arduino boards to connect to the internet over Wi-Fi. This is the magic that enables a device to communicate with online services like IFTTT. Here we have the SSID and password of the Wi-Fi network. It's essential to replace this with your own network details for the connection to work. This line, Wi-Fi client, creates an instance of Wi-Fi client, enabling the Arduino to make web requests. For IFTTT to know it's your Arduino talking, we use a unique URL, part of which is your personal key. This URL is derived from IFTTT's webhook service. Wondering where to get this link? Go to IFTTT, the documentation page, which I earlier told you to save. Copy this address and change the event name according to your requirements. The setup function initializes the Wi-Fi connection and the serial communication. It then checks if the Wi-Fi connection was successful and prints the result to the serial monitor. Now the loop function reads the light intensity from pin A0, scales this value, and depending upon the intensity sends the appropriate message to IFTTT. It then waits for a few seconds before reading again. Send light intensity to IFTTT function. This function is the heart of our program. It creates a GET request to the IFTTT webhook service, sending along the light intensity message and its value. This allows IFTTT to take actions based on these inputs. In essence, what I have built is a bridge between the physical world and the digital realm. Now that we have understood the code, let's piece together the physical side of the things, the circuit diagram. At the heart of our setup, we have the Arduino Nano 33 IoT board. The analog pin A0 is our sensor input. This is where we measure the light intensity. Connected to A0, we have an LDR or light dependent resistor. This component changes its resistance based on the amount of light it's exposed to. The Arduino reads this resistance as an analog value. One end of our LDR is connected to the Arduino 3.3 volt power pin and the another end of the resistor connects to the ground. So in summary, we have an LDR capturing the light intensity, feeding this data to the Arduino Based on the readings, the Arduino then communicates with IFTTT through Wi-Fi using the details in the code. Now let's have a look at the demo video.